Welcome to this chapter on rebuilding of the jf017e transmission. This chapter is divided into 3 parts: teardown, subassemblies, and reassembly. In this part you'll learn about subassemblies for this unit. My name is Jared Warren, and I'll be your host for this chapter. It's a great day to fix transmission, so let's get started. Alrighty. So here we go. We're on the pump here. We're going to start right off. Bottom of the pump, we have 2 O-rings, a small one and a big one. Flow control valve. The flow control valve is the most common issue we have with CVT transmissions. Make sure you do something about the flow control valve. If the bore is worn, you need to ream it out and put a Sonics valve in it. Or Transco has a fix that you do not have to ream out. Has like a steel sleeve, and then Superior has a valve also. So there's aftermarket valves available. Make sure the flow control valve gets taken care of. There's 12 pump vanes go into the pump rotor, and here's the body of it. So we're going to go ahead and assemble this. Now you see the ID marks here face the rear cover. Little tiny ID mark here. This here we're considering the rear cover. There's an ID mark over here in this little cutout. Pump body, there's an ID mark over here on one side by the pin. And then this is the front cover. So to assemble the pump, start with the rear cover right here. With the ID mark up and on the right side. Then you put the pump body with the ID mark up and to the right. So we're going to take this pump body, put it over the dowel pins, so both ID marks are over here on the right. Drop in the pump rotor with the ID mark down. So the ID mark is on the bottom side of this pump rotor, and you cannot see the ID mark, it goes downward. And then install your 12 pump vanes. Okay, so next we have your ID mark here on the right side still. You need to line up this pin in this large hole over here on the right side. So flip it over. Go ahead and install your pump shaft. And then take your housing and put it over the rest of the pump. Make sure there is a little bit of pressure on the O-rings, so when you get this thing put together like this by hand, you should have a little gap here, and that gap is going to be the compression of those O-rings. You need to make sure you have the correct seals in there. Make sure the plug is tightened about 25 foot-pounds. And then we want to torque the 4 bolts here to 10 foot-pounds. It's also a good idea to soak the pump in CVT fluid or pour it into the pump section. This helps the pump on the pump startup. Have heard of some pumps not even pumping if you don't put oil in them, don't prime them, because the vanes stick in and they don't pop out. Have heard of that a few different times. I personally haven't seen it, but I have talked to people on the phone that have had the issue. Alright, so we're going to work on the forward clutch here. So here's the exciter ring here. You want to make sure on this forward clutch we don't get this exciter ring dented up or anything like that. We want a good speed signal. Go ahead and we have your piston and everything, of course, already in here. But here's the wave. Then you have 3 seals, 3 clutches, and the pressure plate. Then we have a snap ring that's 85 thousandths thick, about 195 thousandths wide. Then we have a 70 thousandths thick snap ring here, the ring gear, and then a 70 thousandths snap ring on the outside too. This ring gear, it's a good idea to mark the ring gear to which way is out. It doesn't matter which direction it goes. It can go either way, but me personally, I like to put the ring gears in the same direction as they come out because they wear into each other that way. Forward clutch clearance is about 25 thousandths. And then disassembling this forward clutch is what we're doing here. Compress the balance piston, take off the snap ring, remove the spring retainer. Here's your forward piston. And then right here is the snap ring that's 48 thousandths thick. That goes in the groove right here on the input shaft. Input speed sensor has 48 slots on here. I go ahead and remove the input shaft because it makes installing these sealing rings a lot easier. Go ahead and put everything back together, the piston, your clutch. Leave out the ring gear, and I use just a few calipers and measure the clutch pack clearance here. Again, it's 25 thousandths. There is no spec on this from the factory or anything like that, but we took out apart several drums. The clutches were in good shape, and the clearance is right around the 25 thousandths range. So after you get the put in your snap rings and then your ring gear and your output shaft, or input shaft, and then set it on your pump. Air test right here, and you should hear a nice solid clunk with the forward clutch coming on, and then that's when you need to measure your clearance. And most of these CVTs, if the fluid has not been contaminated, you'll find that a bunch of the reverse brake clutches and the forward clutches are always in good shape. Most of the time I personally just reuse them. There's no reason not to, unless the fluid is contaminated. Alright, so here's the reverse clutch stack up. We have your snap ring for the return spring. It's 51 thousandths. And it goes into the reverse piston. There's two D-rings on the piston. Here's the thicknesses of your snap rings, pressure plates, 3 clutches and 3 steels. And a weight plate on the bottom for the reverse. Reverse clutch is here in the case. So of course when we assemble this in the case, we're going to lube up all your reverse seals and put the piston in, put your spring retainer and snap ring in, and then go ahead and stack the clutches up just like on the last slide. Use your micrometer or feeler gauges and check the reverse clutch clearance. Again, there's no factory published clearance on this, but what we came up with is 45 to 55 thousandths. On the adjustments of both clutches, at this time there is no available part numbers to adjust the clearance. If you needed to, you could probably, best way would be find some snap rings that would be thinner or thicker to adjust your clearance, but you shouldn't have any problems with the forward or reverse brake clearance personally. Alright, so on the rear cover assembly, this pulley without the gear is your primary. Secondary pulley has the gear here. And this is what's different about the jf017e over the earlier CVTs. This one has a chain here. See the chain? So we have a couple chain guides. These plastic yellow pieces are. And there's an oil tube to lube the plastic guides and chain, of course. Park ball assembly here in the back. I use a Posi-Lock TJ1 puller, clamp it onto the secondary pulley. Yeah, I pull on the pulley part instead of the piston part up here, pull down below. What we're going to do is try to remove the tension off this chain. Once you get the tension off the chain, first pull out the 2 chain guide anchors. These right here, the guide anchors. Lubed, there's lube holes here. And this tube's hollow, so the oil comes out here and squirts onto the chain. And then release the 4 locking tabs. So you have 2 tabs. Just grab like a scribe and pull up on these 2 tabs on each side and separate them. Now these plastic guides, all 4 of them are exactly the same. So you can't mix them up. You can't flip them over or anything like that. They're all the same, which makes it nice. Alright, so we have to remove the rear bolts on that hold the pulley in. On the back there's 3 for each pulley. Go ahead and start prying up or pull out on the primary pulley here and also on your secondary. And then once you get them out of ways, you can fold the primary piston out. You can twist it out a little bit. You do not want to twist the chain. You'll knock the little links out if you kink it, or hit with a hammer or pry on it. Those little links will come out and the chain will start to come apart. Nothing like the belt falling apart, but you will damage the chain if you push on one of the pieces here that are the sides of the chain, the links. And go ahead and finish pulling out the secondary pulley. Sometimes you're going to have to pry these pulleys out a little bit, kind of to wiggle them. They're such tight tolerances. Now one thing to keep an eye out for, there's a shim over here on the secondary side. And there's a sealing ring right here, also on the rear cover. There was no shim on the primary pulley. Alright, so let's disassemble the secondary pulley. We're going to go ahead and pull your 40mm nut off. Pull your gear off. You usually get on the back side of this bearing right here and pull the bearing and gear off at the same time. And then you can pull your race off also. You want to check this bearing for pitting, race for pitting. On the rear of this pulley there's a 55mm nut. You do not have to remove this nut unless you're changing like the bearing. Torque's going to be about 150 foot-pounds. Here's the secondary pulley all lined out. You have your fixed sheave right here. What I mean by fixed is it does not move. It's bolted to the rear cover, so this portion of pulley does not move when it changes ratio. The sheave here, this portion is movable, and it slides on 3 rollers instead of having the balls. You change it over to rollers, and the rollers go in the slot here, of course, on the fixed part of the sheave. You have a fairly good size spring in this pulley, so you don't want it popping apart on you. Put a nut on the other side of it, maybe even possibly the gear a little ways, so it can't go flying apart on you. Sealing ring. I like to remove the sealing ring on this piston, and I personally reuse the sealing rings. If the sealing ring is in good shape, a lot of times you can wash it off. Sometimes even take a razor blade and scrape the sides of it if there's any metal in it. If you do replace the sealing ring, make sure you check the fit in the sheave. So take the sealing ring, set it inside here where it's going to ride on the sheave, and make sure the ends are not too loose or too tight. We have heard of some different sizes seals on some of these pulleys that aren't in the overhaul kits. Haven't really explained why, but they do have some strange sizes on one of them that nobody's figured out quite yet where to get the seal. So they may have already corrected that problem by now, but I haven't not seen it, so make sure you check the fit. Metal piston here is pressed on pretty tight, so when you pop this all together, this is what's holding your on the shaft, is right here, the press fit. Now on this outside piston or retainer, oil slinger, whatever you want to call this outside piston, there is no seal on it. And then you have your snap ring. What we have seen and heard a few times now is you pull the snap ring off when you're trying to disassemble it, which is correct. Then you want to get this piston out of there, and all this does is spin in there. It will not come out even if the snap ring is removed. We've heard some pretty stuck ones, but what's happening is it's starting to spin inside the pulley and gall up, and not allowing the piston to go past the snap ring groove. So when that happens, a few different things you can do. Sometimes there's some cutouts here on the pulley where you get the snap ring out. You can take a little Dremel and Dremel this edge right here, the piston, down all the way around. You can spin that piston pretty easy. And then you'll want to, let's see. Oh, if that doesn't work, I have heard of a few people tack welding some nuts right across from each other, so one on each side, and taking like 3/8 slide hammers and popping the pistons out that way. Once you get them out, then you can clean that edge up, and also you may look at getting that piston or replacing that piston because we don't want it spinning in there, creating more metal. So to put this thing back together, you'll want to check your bearings first and all that. Make sure they're in good shape. The exciter ring on this back side of this pulley is very flimsy, very weak. It's just a thin piece of aluminum, basically. It might not be aluminum, but it looks like it. And it just bends every time you tip the pulley over or anything like that. So make sure it's flat and straight, so we have a good speed sensor reading. So you on the primary pulley, you have 3 rollers and guides. So these here is what we're considering the guide, and the roller goes inside the guide, and then you can go ahead and put that up in the sheave and slide it down over the fixed sheave. Check out your sealing rings and your first piston, and press that onto place. This piston locks on this little edge right here, and so it's a press fit and it's tight. Go ahead and put your exciter ring, again make sure it's flat, and then bearing retainer. Put your bearing retainer on and tap your bearing back into place and put your nut on. Go ahead and press that all together. A lot of times that piston is pretty tight on there, so make sure it's all pressed down and you get your bearing and everything stacked up. And then you go ahead and tighten your 46mm nut. Good idea to use Loctite, and hopefully the lines match back up on your way back through. And secondary pulley assembly, go ahead and put the 3 rollers in the sheave right here, and those go in these grooves right here. Put your sheave on, put the spring on, put your other piston on with the seal, clean it just like the other one, or replace it and check the gap. Put your oil slinger into the pulley, snap ring, and then of course inner bearing race, the bearing, a washer, the gear itself, and a nut. Tighten the nut to 50 foot-pounds. Primary pulley assembly. Kind of went over this already a little bit on teardown. Here's your 3 rollers and keys. Put them in. Put your pulley down. Press your piston into the pulley. And then check your exciter ring. Make sure it's nice and flat and nothing's bent. Put your backing plate on, or bearing holding plate. The bearing itself, and then the nut. Some of these primary pulleys, you're going to find a spring in them. So the question always comes up that yours had a spring in it originally. The core that you got, there's no spring in it. So what do? I simply take the spring out of the original unit and I put it into the new or rebuilt pulleys that you found, and press it all together, and then put your gear and bearings on. To me, it seems a lot easier that way. Now here's a chain assembly. It looks a lot like the Subaru CVT chain. You have your 4 guides. Yeah, four locking tabs, 2 on each tab. These little tabs here on the side, these fingers here and here on both sides, those are what clips onto the oil tube. So now once you got the pulleys all assembled, you're going to want to put a puller on the secondary and pull out the tension off the spring, or add tension to the spring by pulling up on it. Hopefully then you'll be able to put your primary pulley inside the chain, and then at that time you drop that onto the rear cover. A lot of times belts will be held together by zip ties and stuff like that. The only thing I do on the belt usually is I take a small zip tie and mark one side of it, one edge of it, so I know if I won the money for one thing, and then kind of keep check on myself. Alright, so go ahead and put the positive lock puller onto the the secondary pulley, and relieve the tension to spread that pulley apart. Then go ahead and put the belt on, or the chain on I should say, with the chain guides already assembled, and then tip the primary pulley up into the chain, and use a couple of zip ties here in the center to kind of keep it together. Then you take some 8mm by 1.25 threads, studs, and we're going to put them on the bearing retainer right here, one on each pulley, to help line us up on the rear cover. So here you see the studs threaded into the retainer. We want to make sure we put the shim in this rear cover, and the sealing ring in the rear cover. Then you take both assembly and go ahead and slide the pulley assembly into the cover, lining the studs up with the retaining bolt holes. Go ahead and remove the zip ties at this time, and then you can do hand tighten a couple of the retaining bolts from the back of the cover. Valve body. Here's the lower valve body. We're going to want to check a few different things. If you're having like lockup issues, you're going to want to check your TCC control valve and your TCC regulator valve here. Make sure both these little plungers are nice and free and not worn. Make sure the bore in here is not worn. Like vacuum test right here would be one spot, and then right here would be another spot. If you're in vacuum testing. For pressure issues, ratio change issues, that kind of thing, we want to look into this pressure regulator bore right here. Make sure the valve's not worn and the bore is good, and it vacuum tests. And then we have secondary reducing valve. This is right here in this bore. And this is the lower section of the valve body. So right here is the other view. And one thing I'd like to mention, the filter on this one, the open end goes into the plate, and the solid end goes down towards the valve body. Alright, so here we are with your solenoid ID. We have your select solenoid, line pressure solenoid, your secondary pressure solenoid, primary pressure solenoid, and your TCC solenoid. Then we have the two switches on top also, a primary pressure switch and a secondary pressure switch. To retain these little, the solenoids, they have these little pegs that go in here. Make sure you don't lose these pegs. It's kind of easy for them to fall out. It's kind of a different way of holding the solenoids in also. The temperature sensors on the wiring harness right here. And then here's the internal wiring harness. One thing about these wiring harnesses, there's some differences out there on Jeep and Nissan. So if you're swapping valve bodies around on this stuff, make sure the wiring is the same. Some are grounded to the valve body and some are controlled through the TCM. So make sure you know what you're working with and the wiring harness is the same if you're doing some interchanging. We've heard of some electrical meltdowns, some problems with wiring them in the wrong vehicle. So all the solenoid resistance are 5.5 to 8.5 ohms, except the TCC solenoid, which is 6.1 to 7.7. Here are check ball locations. So we have our 4 check balls here. All 4 of these check balls are for engagement feel, 2 for reverse, 2 for forward. If you have an engagement problem, check those check balls real close. Pilot valves. Pilot valves are very important. They're basically solenoid regulator oil, so it controls the oil to the solenoids. If the solenoids don't have a regulated pressure to them, they're not going to be able to regulate the pressure to the pulleys correctly. Here is the primary reducing valve. It likes to wear at times too. So basically this whole section of valve body, you need to check it real close for wear. Make sure you pull every valve out of the valve body one at a time and clean the boards and make sure the valves are nice and free. That's not usually my type of building personally, but with the CVTs, every valve needs to come out and hit the bench, you know, and clean it up, because whatever that black grit stuff is in these transmissions that they all produce, it gets in there and hangs these valves up, and you can pick it just fine, but the valve itself will stick in the vehicle. This filter in this one, the open end is down into the valve body itself, solid ends up towards the plate. We're going to install one spring in the large check ball right here. And then going to go ahead and put this valve body together and torque all the valve body bolts 70 inch-pounds. So again, common issues of this trans: flow control valve wear, major problem. It's always sticky in the pump board is always worn. So make sure you get that taken care of. Like I just said, all valves in the valve body needs to hit the bench. Needs to be cleaned out. And sticky valves are an issue with this. If you don't pull the valve body completely apart, you are going to have some problems. And usually you can fix those remedies just by cleaning the valve body itself. Charging system, make sure the battery is charging the correct voltage, and the battery is up to 12.5, 12.6 volts static charge. When it's charging, it should be around 14 volts. We have had issues overcharging and undercharging, so make sure that's taken care of. And I can't say this enough, make sure there's no more codes in any system, ABS, ECM. Make sure all codes have all modules have no codes in them. It will cause relearn problems, and it definitely affects transmission. This will conclude the subassembly part of the jf017e transmission. We want to thank you for participating in our virtual training solution powered by ATRA. Until next time, let's keep fixing transmissions together.